All right, hello everyone, and thank you for attending this talk about the qualification of the C and C++ standard libraries. This is especially relevant when using RISC-V within safety-critical software, for example, for automotive applications. Let me start with a short introduction about Solid Sands. We are based in Amsterdam, the Netherlands, so it was quite a trip to get here, but I'm very glad to be here physically again. And our company was founded in 2014 as a spin-out of a compiler development company. As part of the compiler development was also the maintenance of a test suite for C and C++ implementations. And in 2014, it was decided to put that test suite on its own feet to focus more on extending it for the latest versions of C and C++, and also to focus on safety-critical applications. So that is how Solid Sands was born, and since then we are the one-stop shop for C and C++ compiler and library testing, and for related validation and safety services. We have customers worldwide, which is very nice because we are from such a small country, we are still making an impact all over the world. All right, even though my talk today will mainly focus on library testing and library qualification, I think especially in the context of RISC-V, it's also very relevant to talk about compiler testing for just a minute. So with our product SuperTest, the compiler test and validation suite for C and C++, you can test compilers to make sure that they are compliant with these C and C++ specifications. So basically our test suite has a test for everything that is written in the specifications. Our test suite is organized following these specifications. And this way you make sure that for everything that is written there, there's a test that verifies that the compiler correctly implements it. Upon that, of course, we have a very strong background in compiler development, so we go far beyond just compliance testing. We really test the compiler in and out by testing compiler internals like optimization, data model-specific arithmetic, calling conventions, and so on. So with SuperTest, you really make sure the compiler is tested in and out. And of course, within RISC-V, this is actually very relevant because RISC-V is a relatively young architecture. Compiler development is still happening a lot here. And also RISC-V, of course, allows for instruction set extensions that the compilers need to take into account. So that is why, for example, Sci5 uses SuperTest to make sure their toolchain is of the highest possible quality. And also CodaZip uses SuperTest to verify their compiler backends with instruction set extensions. Now, compiler testing is not only relevant when building a compiler, it's also very relevant when using a compiler within a safety-critical context. When doing that, and when using C or C++ for a safety-critical project, you need to be compliant with functional safety standards. And functional safety standards tell you to create confidence in the tools that you are using, including the compiler. So ISO 26262, for example, for automotive software, requires you to create this confidence mainly by showing compliance to the C and C++ specifications. And that is, of course, where SuperTest then comes in. Of course, getting this confidence in the tool, you also get from the additional tests for compiler internals that are really testing the compiler in and out, and that way you really know for sure whether the compiler is doing what it should be doing. Or if the compiler is miscompiling certain code constructs, you are aware of it, and you can work around it to make sure that it doesn't impact the safety of your application. Finally, important to note here is that compiler qualification is use case specific, and it means that you qualify a compiler for the configuration of the compiler that you are using for your software. Because as you can imagine, if you're using optimization or not, that really changes the behavior of your compiler. And similarly, if you're using an instruction set extension or not, that changes the behavior of the compiler, and therefore you really should qualify a compiler for the exact use case you are using it for. Now, when using C or C++ to implement an application, it's also very likely that you're using the standard library of C and C++ to implement parts of the functionality. Also there, functional safety standards require you to qualify the library that you are using. And compared to tool qualifications for compilers, for example, the requirements here are more strict. While for tool qualification, it is sufficient to show that you have tests for everything that is written in the specification, which we provide by a mapping between test cases and the C specification and the C++ specification. For C++, you really need to do requirements-based testing, just like what you would do for your application testing. And the reason for that is that the standard library is not a tool. It's actual code that is part of your application. It is loaded into your safety-critical device. And in the end, it's just software, and software really needs to be tested properly. So therefore, you need to do requirements-based testing, you need individually labeled requirements, you need test specifications explaining how you are verifying these requirements. And the biggest challenge here is that the ASIL C and C++ specifications do not provide directly testable requirements. And we will just take a look at that in a minute. So basically, the C and C++ specifications, they contain descriptions of what library functions should do, but it's really just a description. It is not a set of requirements. On top of requirements-based testing, you also need to do code coverage analysis when you're targeting the highest possible safety integrity levels. And code coverage analysis is then used to demonstrate the completeness of your testing as additional evidence. So I just mentioned that the specification of C and C++ is not directly usable for requirements in terms of requirements-based testing of the library. And an example of that we can see here for the specification of the string ncopy function. So these 4 sentences about the string ncopy function is all that there is written about the string ncopy function in the C99 specification. And let's now try to break it down to see whether it's possible to do requirements-based testing using this text or not. First of all, let's take a look at the specification of the prototype of the function. So the string ncopy function takes a pointer to a character S1. It takes a pointer to character S2, which is a string that is being copied to S1. And then size tn, which is the maximum number of characters that should be copied. Now, let's start with the good news, and it is that the bottom 2 sentences are very clear, they are very straightforward, and they can be directly used for requirements-based testing. All we need to do here is give these sentences a label, and then they become a requirement that we can use for a requirements-based test suite. But looking at the sentence above there, it already gets a bit more problematic. This sentence here states that if copying takes place between objects that overlap, the behavior of the string ncopy function is undefined. So actually, it says that there's no requirement at all on the function if copying takes place between overlapping objects. So that means when creating a requirements-based test suite, this is not something that should be taken into account at all because it's not a requirement on the implementation, it's a requirement on how the function is being used. So the application developer should make sure that he is not calling the function with overlapping objects. So it becomes a precondition to this function, and it is not an implementation requirement of this function. Even more problematic is this sentence above. It states that the string ncopy function copies not more than n characters. So actually it says what the function should not do, and it does not say what the function should implement. And if you would read this very pedantically, you could even understand it as if the function never has to copy anything, because then it's copying not more than n characters, and it would be compliant with this specification. Now, obviously, knowing what this function should do, that is not the case. But when creating a requirements-based test suite, you really need to make it specific and explicit what the function should be doing, because only that way you can reliably test the implementation of the function. So what we have done is we have analyzed this text from the C specification, and we have actually created testable and directly usable requirements for it. The top 2 requirements we see here are based on the orange piece of text that we just looked at, and they now make very explicit what the function should do when it's being called with a value of n and a string that is smaller than that, and what should be happening if it's being copied with a value of n and a string that is equal size or larger than that. And based on these requirements, we can then create tests that are clearly verifying the behavior of what the function should actually do. The 2 green requirements on here, those are directly taken from the specification, and we have given them a label because, like I said, they are directly usable for requirements-based testing. Finally, the bottom 2 blue requirements over here do not come from the specification at all. They come from expertise and knowledge about what goes wrong when implementing a function in C. So for example, we are writing that the function should never write into the target array S1 beyond the first n characters, because it would be a buffer overflow, and you know all kinds of safety issues could occur there. So by adding these requirements and really making it a complete list of what the function should implement, we can then reliably test the implementation of a function like string ncopy. So this is what we have done for the entire C standard library. And based on that, we have created our product SuperGuard, which is our requirements-based test suite for the C standard library Qualification. We have created a detailed breakdown of the C library specification into implementation requirements that we just looked at. We have written test specifications that explain how these requirements are being verified by our test suite. And then, of course, we have actual test cases that perform the verification of the requirements. Out of the box, we have made sure that our test suite has high structural code coverage on common library implementations, because that gives additional evidence and confidence about the completeness of our testing. And in the end, everything comes together in a software tool that generates documentation with all the requirements, all the test specifications, and then the test results that you can use to demonstrate that you have indeed qualified the library following the requirements of ISO 26262 or a similar safety standard. Now, the first question we got when announcing our product SuperGuard was, when are you going to support C++ as well? Because C++ is very popular nowadays, and it's a lot being used within safety-critical product development. So, of course, we are now working on creating a requirements-based test suite for the C++ standard library as well. And there we are applying our lessons learned from C library qualification. So again, we are looking at the C++ specification, we are creating implementation requirements, and that way we are building a requirement-based test suite. But the biggest challenge here is that compared to C, C++ standard library is a lot bigger. And at the same time, C++ is evolving very quickly, because every 3 years, a new version comes out, which might add many new features to the standard library. Therefore, we are now working together with our customers to look at popular subsets of the C++ standard library that are being used within the industries where we are working with our customers. And that way we make sure that we can still create a very valuable requirements-based test suite for C++ without needing to cover everything that might not even be used in the industry. So we are expecting to have a first requirements-based test suite for a subset of C++ at the end of next year. Finally, on top of the size of the C++ standard library, we have an additional challenge here, and that is code coverage analysis. And the challenge here is that C++ is, of course, a lot more advanced than C. It's adding very powerful features on top of C, but some of these features make code coverage analysis quite complicated. A good example of that is compile time evaluation. Compile time evaluation allows a developer to say that a function or a statement is cons expert, which means that the code is being computed by the compiler instead of it being compiled and computed on your target. And a good example of that you see here on line 14 in the if then else statement. The if then else statement is computed by the compiler, and only the result, which is line 15, ends up on the target. The problem here is that many code coverage analysis tools, they instrument source code, compile that instrumented source code, and then execute it on the target to, at runtime, decide which parts of the code are being executed or not. But when code is being computed by the compiler already, this information gets lost. And the challenge here is that a lot of code in the C++ standard library is declared to be cons expert. So even though we are covering it, like function foo on line 1 to 3, which is being called on line 14, the code coverage analysis tool is simply telling us we are not covering it at all. So to be confident about the completeness of our test cases, we need to do additional analysis. We need to improve code coverage analysis tools to make this possible. And therefore, we are talking to developers of such tools to make them aware of the issues we are facing and to see if there can be, the tools can be made more suitable for library qualification. Finally, another challenge is that a lot of code in C++ standard library is in header files and not in source code files. And many of these code coverage analysis tools, again, really look at source code files and don't consider header files as any source code. And then, again, they simply ignore them. So this is another detail that we are discussing and making these developers aware of to make sure that these tools become more suitable for library qualification. That wraps it up. I hope I gave you a nice overview of compiler and library qualification today. If you would like to further discuss this or talk about common subsets of C++ that you are interested in, then please make sure to visit us at booth number T6. And we also have some very nice goodies there, so make sure to pass by. Thank you all, and let's go on to the Q&A session.
Sure, thank you very much. There's 2 questions from the online audience. So first one, C and C++ allow undefined behavior. How do you verify that?
That's a very good question. And what I mentioned when decomposing the standard here, actually on the implementation of the function, undefined behavior is not a requirement, because the implementation does not need to implement anything because the behavior is undefined. So instead, this is a precondition on the function, and our report generators out of SuperGuard list those preconditions on the functions to make developers aware of them. But on top of them, the common way of handling this is using a analysis tool, a static analysis tool that makes sure that indeed the function is not called missing the precondition. And in automotive, a very common way of doing that is using the MISRA coding guidelines and MISRA coding checkers, which warn you about utilizing undefined behavior in the standard library.
Thank you. One more question. So do you plan to create a test suite for Rust?
Also a very good question. So we are definitely keeping our eyes open here. We are not blind for only looking at C and C++. And indeed, we see that Rust is becoming more popular in the industry. A challenge here is that Rust does not have a standardized and fixed specification like C and C++ have. So it is more challenging to create a fixed test suite for it. But we are definitely looking at ways to do that and keeping our eyes open to see the development of Rust and seeing it become more mature, and then that is definitely an option. Yeah.
Okay, so questions over here. Anyone? Questions?
Thank you for the string and copy example. It was really easy to understand. And what will be an example for the functional safety 26262 for a similar function in C or C++ library?
Yeah, that's a very good question. So the requirement from ISO 26262 for the standard library or any library that you might be using is that you need to qualify the library that you're using. And the way of qualifying the library that you're using is doing requirements-based testing. So that is exactly what we have created SuperGuard for. We have made the specification explicit. We have made requirements out of that, such that you can perform requirements-based testing. So with our product SuperGuard, which is the requirements-based test suite, you can then perform the testing and create the reports that are needed as evidence for ISO 26262. And also the test cases in the test suite, we have made sure that they are compliant with what ISO 26262 requires. So for example, we are specifying equivalence clauses and boundary values, all to make sure that everything that's required by these standards is being covered by our test suite.
Any more questions? I'm going there first.
So on the compilers, do you do static code analysis and dynamic code analysis as well? Dynamic categorically?
Yeah, so for compilers, our test suite is basically a very large collection of source files that target specific constructs in the language, and also it targets the constraints of the language. So those programs we feed to the compiler, and the runtime tests we run on the target, and we verify that the behavior is as expected. And the test for constraints, we verify that the compiler gives a proper error message, such that no invalid code ends up in your device, which might, of course, also be a safety issue. So by doing that for the entire C and C++ specifications, we make sure that the compiler is compliant with its specification.
Okay, thank you.
You're welcome.
We have one more question here, and I think this is the last one.
You mentioned you were adding support for C++, like a subset. What's the subset people have been most interested in?
That's a very good question. So we see in automotive that there's indeed some common classes that are being used a lot. So containers, of course, are very popular. From the top of my head, utility header is a lot of functionality that is being used. And so there are some more. From the top of my head, I don't know all of them. But if you visit our booth, I would be happy to talk about it in more depth.
So I think that's it. So thank you very much.
Thank you.